Okay guys, this is the solution for the first potential C1 paper. So question 1 is 27 to the 2/3 plus 32 to the 1/5 squared. What I did is I wrote 27 as 3 cube and 32 as 2 to the 5, and then I cancelled it, and then you get 3 squared and 2. So you get 9 plus 2 all squared, which is 11 squared, 121. Question 2, fx equals to 16x squared minus 40x plus 25. So a is equal to 16, b is equal to minus 40, c is equal to 25, and the discriminant is 0, so there's only one root exactly. Question b, so this equation equals to 10, you take the 10 away, it becomes 15, and then what I did is I took the 16 out of the bracket from the first two terms only, and I completed the square and multiplied it out again, and you get this as the solution on the right hand side. 5 plus or minus 2 root 35 over 4. Okay, and question 3, we have 3x squared minus x minus 10 less than 0, which is 3x squared minus 6x plus 5x minus 10 less than 0. I factorized it and then I sketched the graph as you see, and you must show the graph every time guys. If you don't have the graph you will lose marks, and the region needed is x less than 2 or greater than minus 5 over 2. Question 4, so a is 1, 7, b is 2, minus 5, c is 3, 4. Midpoint is obviously 3 over 2, 1, and then you find the equation of the line from midpoint to c. You worked out the gradient and then you put it into the equation. Okay. And question 5, probably the shortest question in the paper. Integral of 4x cubed plus 1 over 4x cubed dx, so that would be integral of 4x cubed plus 1 over 4x to the minus 3. Now a lot of people bring this 4 up on the second term. Make sure the 4 doesn't come up. Okay, when you integrate it, it becomes x to the 4 minus 1/8 x to the minus 2 plus c. Question 6, a is the sum of I equals 1 to 60 of 40 minus 5r, and a equals 40 minus 5, which is 35, and a 60, the 60th term is 40 minus 300, which is minus 260, and I use the formula Sn equals n over 2a plus l, and you get minus 6,750 as the answer. And for b, it's the same thing really, you just put n instead of 60, and you get n plus 2 over 3 for the last term, and 1 plus 2 over 3 for the first term, and then you use the same formula, and you end up getting n over 6, n plus 5. So k is equal to 1, 6. Okay, if you need to follow the steps, just pause the video and just go through it slowly. Okay. Question 7, dy dx is obviously that. So when you simplify this, x squared minus x plus 4x to the minus 2. So d squared y over dx squared is 2x minus 1, 8x to the minus 3. So to get the y, to integrate dy dx, so you just integrate the simplified version already, which is x squared minus x plus 4x to the minus 2. When you integrate, you get x cubed minus half x squared minus 4x to the minus 1 plus c. And when x equals to 0, sorry, when y is equal to 0, x is equal to minus 2, you just sub that in and you get the constant as 22 over 3. And then you write the equation down, which is y equals to x cubed over 3 minus half x squared minus 4 over x plus 22 over 3. So when x equals to 3, you plug the 3 in and you get 21 over 2. Okay, so that leaves us to question 8. So the third term was a plus 2d, which is 5. The fourth term is a plus 7d, which is minus 33. So what I did is I took the second equation minus the first equation, which is 5d equals to minus 38, and d is equal to minus 38 over 5. And then to get the first term, I just, well, you need to work out the first term to work out the sum. So I worked out the first term, which happens to be 101 over 5. And then I put that into the equation Sn equals n over 2a plus l to get the sum of the first 8 terms. Because we already have the 8 terms, so I kind of used this equation, which is easier. Or you could use it n over 2a plus n minus 1d as well, which might be a bit longer. And then the answer is minus 320 over 5. For part B, it's quite easy. So a is equal to 35, d is equal to 7, n is equal to 10. Last term would be 98. So I kind of worked out there are 10 terms, and then you just use the same equation. Okay, I use this sum equation quite a bit in this paper just for practice. Okay, there you go. The sum happens to be 665. Question 9. So 5x squared minus px plus p minus 2 equal to 0. So a is equal to that, b is equal to that, c is equal to that. So the discriminant is greater than or equal to 0, and you get this quadratic inequality. And all I did is I completed the square. So I know at the end I get p greater than or equal to 10 plus or minus root 10, but you got to make sure you sketch the graph again and shade the region, and then you actually get p less than 10 minus root 10 and p greater than 10 plus root 10. So the smallest positive value for p with equal roots would be p equals to 10 minus root 10. So if you plug that into the p of the main equation, you get the following. So 5x squared minus 10 minus root 10x plus 10 minus root 10 minus 2. So if you simplify a little bit, it would be 5x squared minus 10 minus root 10x plus 8 minus root 10 equal to 0. That's question 9. Now question 10 part A, award yourself full marks because it's a wrong question. Clearly it has 3 intersections when you try to solve it, so just award yourself the full marks for question A. But question B and C we can do. So dy dx is equal to 3x squared minus 4x minus 7, and when x equals to 2, dy dx happens to be minus 3. I accidentally work out the not tangent there, but if that happens in the exam, you just simply cross it like that and then you go to your normal. So m of normal is minus 1 over minus 3, which is 1/3, and then normal is y minus 6 equals 1/3 x minus 2, and you get 3y minus x minus 16 equals 0. So they're telling us this normal crosses the axis at a q and r. It doesn't say exactly which one's q, which one's r, so it doesn't really matter. So you just put at q y equals 0 or x equals 0, it doesn't really matter. So you get x equals to minus 16, and I put x equals 0, then y is equal to 16 over 3, and you just write the coordinates clearly. You might get marks for these coordinates. So I wrote my q minus 16 0 and r 0 16 over 3, and then you just basically just simply work out the distance. Okay, you can simplify as much as you can. Okay, obviously it will take some time, but it's better to simplify and leave it in a nice third form, which happens to be 16 root 10 over 3. Even if you leave it as 256 root over 3, that's fine. Okay, so that's the solution for the first paper. The second paper will go up shortly.